Hi everyone, my name is Ruv Sharma and I welcome you all on our next exciting session on setting up Remote Access VPN solution on Cisco ASA or Windows VPN Client, not on Cisco AnyConnect, but on Windows VPN Client using EAP TLS authentication mechanism. So we had a session previously where I demonstrated how we can set up certificate-based authentication on Cisco ASA using AnyConnect VPN client, where the users were authorized using Cisco ISE. But in this case, we are using Remote Access VPN solution using Windows VPN client or EAP TLS. On that note, let's jump in. Well, as I mentioned, the knowledge of how to set up authentication on or set up the VPN connection on Cisco ASA using IKE v2 is not new. It's pretty common, but there is a twist. The twist in the story is, in this case, the user, let's suppose is user X, is trying to connect over a VPN terminator. In this case, we have Cisco ASA. The user will be authenticated and authorized using certificate. Let's suppose this user is user Vinod. And user Vinod is issued a certificate with a private key installed on it. The CN would be Vinod. And the CA who assigned the certificate to user Vinod is Cisco. So user will be when we are trying to configure EAP TLS based authentication, the user, when it tries to connect to the VPN, it has to provide its certificate to Cisco ASA. But remember, here is a twist. If you remember my previous session where we have configured certificate-based authentication, in this case, in certificate-based authentication, the user or the VPN endpoint machine or a user provides his certificate to Cisco ASA, and Cisco ASA performs authentication. And for authorization, ASA used to contact Cisco ISE. So if you want to see how this is configured, please refer to my previous video where I have given a very good demonstration how that certificate-based authentication works. So what happens over here, the ASA will go to authenticate the certificate. We install a root CA certificate of Cisco ASA on it over here, which is Cisco. So a root CA is installed on Cisco ASA over here, and once the user provides its certificate to Cisco ASA, ASA will authenticate whether the certificate is correct or not. Once the authentication happens, ASA forwards a query of authorization to Cisco ISE. And later what Cisco ISE does, it basically check whether this user Vinod is a part of right AD group. If it is yes, under the authorization rules, it will provide a right authorization profile on Cisco ISE. That's how we did the certificate-based authentication on Cisco CA or on Cisco ASA. But with EAP TLS, there is a twist, and that's why I thought it's worth having a session, because I literally struggled a bit setting this up. So I thought, let's share with everyone how I achieved this objective. So what happens is with EAP TLS, the Vinod, the end user, still provides a certificate. That's a certificate, but this certificate is not sent to Cisco ASA. Cisco ASA tunnel that certificate back to Cisco ISE, and Cisco ISE, which is the Radius server, performs authentication authorization, and accounting. So all the three AAAs are performed on Cisco ISE, not on Cisco ASA. Cisco ASA just act as a VPN terminator and forwards all the credentials what is received by the endpoint to Cisco ISE. In that case, ISE plays all is a very focal point of authentication, authorization, and accounting, and ASA totally relies on Cisco ISE for all for all the three A's, that is authentication, authorization, and accounting. That's the difference between setting up a VPN solution using certificate-based authentication or a EAP TLS-based authentication. Well, we'll be achieving this objective in just simple 5 steps. The step number 1 is to arrange the certificates, set up ASA, set up ISE, set up the VPN client, and verify the connection. I will be giving you guys a quick demonstration as well to show you how this really works in our lab environment. This will be the topology, guys, we'll be using. This topology, I have an end machine where the user Vinod. We'll be using Windows-based VPN client, not Cisco AnyConnect. It will be Windows-based VPN client that is trying to connect over the VPN using EAP TLS IKEV2. The user laptop has an IP of .34, and the ASA outside IP is 11.1. This ASA IP resolves into vpn2.cisco.com, and there is a trust point created on Cisco ASA facing the public internet. Obviously, my lab is pretty simple. I don't have internet, but still, I have a DNS server that resolves 11.11.11.1 to vpn2.cisco.com, and user will be contacting the public 11.11.1 using vpn2.cisco.com. There is a trust point created as well. And we have a Cisco ISE that has an IP of 1111.12 that connects to ASA over the management interface. And there is an inside interface as well on the ASA. Well, step number 1, there is a certificate requirement, guys, and that's absolutely important. So if you refer back to my topology, if I take you back, this user Vinod must be installed with a private root CA that identifies user Vinod. So the user Vinod must be installed with a CA certificate which is assigned to user Vinod. And this issuer of the certificate, let's say it's Cisco. CA is Cisco. So CA Cisco issued a certificate to user Vinod, and that user certificate must be installed in the laptop. And this user Vinod's this is the same certificate which will be sent to Cisco ASA for EAP TLS authentication. And remember, as I mentioned in my previous slide, ASA will not perform neither authentication nor authorization. Everything will be done over Cisco ISE. Going back, so the first step is the user authentication. User authentication, we need to install a certificate for user-based authentication, and we need to install a certificate with a private key on it on the user laptop. If I give you with the picture, that's the certificate on user PC, Vinod, and the CA is Cisco. And this Cisco CA is also installed in its trusted root CA as well. So we need to install the issuer of the CAs must also be installed in the trusted root CA as well. Going back, ASA must also be configured with the certificate facing the internet. If I go back to the topology, this interface 11.11.11.1 outside interface must also be, which resolves into vpn2.cisco.com. It also must be assigned a certificate, and this certificate CA can be Cisco or Entrust. or any public CA as well. So we need to make sure a certificate is installed on the interface gig 0/1 facing outside internet space, which is issued by Entrust CA. And finally, the Cisco ISE. Cisco ISE must install the root CA of the certificate, which is the issuer of the certificate for user authentication. What I mean that if I go back, oops, sorry, pardon me. I'm playing around with, with the slides. Yes. So this CA, Cisco.com CA, must be installed in the trusted root CA of Cisco ISE. That's the simple certificate requirement, guys. First, install the private root CA, private certificate on the Windows machine. Second, the issuer of the CA, the root CA, must be installed into Cisco ISE as well. That's the certificate requirement, that's the screenshot. You can see that CEHCA is installed on the user machine. Cisco ISE is also installed with the root CA CEHCA under the trusted root CA authority. That certificate must be installed into the Cisco ISE as well as a prerequisite as part of step 1. Coming back to step number 2, where we need to set up Cisco ASA. Well, configuration on ASA is very minimum, guys. Now you can see we just have configured a random group policy, Cisco Ops VPN group policy, nothing major. I won't be explaining you about what is group policy or what is how to set a VPN. I assume the audience of this video knows what group policy is. So that's one of the VPN profile which is used by the VPN endpoints to connect to the VPN. So you can see we have issuing the DNS server, IKv2 tunneling profile, Cisco.com, and the address pool for the VPN endpoints. Finally, just a tunnel group, right? Which says to authenticate using Cisco ISE. As I mentioned, ASA is not doing any authorization or accounting. It's not authenticating, nor it is authorizing. And we are saying it needs to be certificate based, although ASA is not authenticating anything. And we are saying that for IKv2, remote query should be using EAP query, using EAP based authentication. And IKv2, the local authentication will be vpn2.cisco.com. See, there are two commands you can see, remote authentication and the local authentication. Remote authentication says that how the remote endpoints, which is user Vinod on the laptop, must be authenticated, right? So the user Vinod, the endpoint must be authenticated using EAP, where the user will provide its certificate to ASA, and ASA will just forward it back to Cisco ISE. Job done. Boom. Chapter close. But ASA will also perform the local authentication. What it means that the user connects to Cisco ASA, and ASA external interface. This interface is basically vpn2.cisco.com. So this authentication, where this issuer of the certificate is Entrust. When Vinod will try to communicate with this URL vpn2.cisco.com, the user machine will also see whether I trust this CA or not. That's why it's an optional configuration, which I will explain you in couple of slides from now. You may set the set up the VPN profile on this end machine to trust whether you want to trust this CA or not. So Entrust root CA must be installed on Vinod's laptop as well. So it's a local authentication that happens locally on Cisco ASA, whether it is checking whether who is trying to connect to me or not. So that kind of authentication happens locally, and this is for the end users. And finally, the Cisco ISE configuration, which is pointing towards Cisco ISE. And my key is Cisco. Obviously, you won't be using it in your production environment, but since it is a lab environment, we can use it. So that's the configuration we need to use it on our devices. If you are trying to set up something similar, you can use this configuration in your devices. And finally, it's an IKV2, right? So how to set up IKV2? I used this set of configuration to set up IKV2 on our ASA. This is the policy. It's pretty simple. So I'm not spending so much time to explain you about how tunnel groups or how AAA configuration is done on ASA, because I believe it's something you guys must already know it, and because it's already on the internet how to set up IKV2 and how to configure it over the ASAs. You can see we are enabling IKV2 on the outside interface, connecting it to the trust point, and I assume everyone knows how to configure trust points on Cisco ASA. And finally, the dynamic maps. Now we're going to configure Cisco ISE, where we created a profile under the network devices ASA, and that's the IP of Cisco ASA, 111.55. If you go back to the topology, Cisco. And finally, we configure the authorization profile. So what we say that if you go back to, if you would have noticed on the Cisco ASA tunnel group configuration, there is no group policy configured. So we are not configuring any group policy. Whomsoever connects to the remote tunnel group, they will not automatically get a group policy, guys, because there is no group policy configured to it. And point to remember, since we are using Windows VPN client, not an AnyConnect VPN client, we can only use default RA group on Cisco ASA. If we create a custom tunnel group on Cisco ASA using Windows VPN client, it won't work. We can only use a default RA group tunnel group on the ASA. And we can see that under the authorization profiles, what I've configured, once the user is authorized, he will get a group policy, Cisco Ops VPN group policy. Once authorization is performed, and we will manually attach this authorization profile Ops VPN onto it. Well, authentication policy is pretty simple. We have configured a NAS IP, which has an IP of Cisco ASA. We have given a tunnel group name, default RA group. That's the profile you can use in your own lab. And we have used a certificate-based authentication. We're using a default certificate profile. And under the authorization policy, what we have done, the user, if the user is part of AD group operations, then he will get a authorization profile, which is Ops VPN, and the NAS IP is 111.5. So if these two conditions are met, then the user will get an authorization profile, which is Ops VPN. And Ops VPN will give a user a group policy, which is for operations. Well, finally, we need to set up the VPN client, and we just have to follow these simple steps. We need to go into your Windows configuration, network and internet and VPN, add a VPN client, specify, give a name EAP VPN, give the server endpoint name vpn2.cisco.com, IKV2, leave these fields empty and save changes. Under if you open this configuration, you can follow these steps to configure your VPN endpoint. So you don't need to you should not select smart card based authentication. You should say that I'm using certificate based authentication installed on the certificate. And if you remember, I've unchecked this option of verify the server's identity by validating its certificate. What I'm trying to say is if I check this option, then this user PC of Vinod, when it tries to connect to the VPN on the ASA, this link is issued to vpn2.cisco.com, and this CA, issuer of the CA is Entrust. If I check this, if I check this box, then I need to install Entrust root CA into my root CA authority in my laptop. So we need to make sure that Entrust root CA is installed into the machine, and that's why since I avoided that step, I have unchecked this option. If you have the root CA installed in your machine, you may check this box as well. And finally, the EAP authentication is successfully performed, and we can verify the user is authenticated. The user is authenticated using the authentication policy and authorized using authorization policy. It's pretty evident the user is not authenticated nor authorized on Cisco ASA. Since we are using EAP TLS based authentication, the user is both authenticated and authorized on Cisco ISE, not on Cisco ASA, since we are using Windows-based VPN solution. For reference section, I referred back to this Cisco document, and you can get to the link from the slides. You can get to the slide from the description section below. I think it's time to go for a head towards the demonstration. I will bring up my lab, guys. Bear with me. Okay. Mhm. Okay, so that's my Active Directory. That's the Windows VPN endpoint, which is basically the endpoint will be used for connecting to the VPN. Before I give you a demonstration, let me quickly bring up the topology as well. So bear with me. So what was it in the topology? So here it is. The user Vinod, as we saw, the user Vinod has an IP of 11.11.11.34, will be connecting to a VPN on the Cisco ASA. It's my lab. It's not coming from any production environment. That's why I'm using these random addresses. But technically, they obviously in the production LAN, the user laptop will never have an IP from the same interface, same LAN of Cisco ASA. But just for my lab's sake, the topology is pretty simple. The user Vinod has an IP of .34, and it is able to resolve or ping 11.11.11.1. If I go back and try to show you, okay, 11 ping 11.11.11.1. Yes, I'm able to connect to the external interface of the ASA. And this is the ASA. If I quickly show you the configuration of the ASA. So that's the configuration which I've pasted on the slides as well. It's pretty simple, where the tunnel group configuration, it is authenticated using Cisco ISE and authorized using Cisco ISE. And that's the default configuration we need to put it. If you're setting up EAP TLS based authentication in your environment, you can just use the same configuration which I've pasted on the slides. And finally, if you see, there is no group policy configured on this tunnel group, and the group policy configured over here is just Cisco Ops VPN group policy. That's it. The configuration is very minimum and very basic. So I don't think there is any, because all the magic is happening on Cisco ISE, guys. So nothing has been configured on Cisco ASA. And finally, crypto IKV2, as I mentioned, IKV2 configuration, which I've pasted it. And I've even pasted all the configuration which we need to do for IKV2 in the slides as well. So, but there are enough documents from Cisco which explain you what are the basic configuration which are required for Cisco ISE. But I believe it's pretty evident, and it's pretty easy to understand how we can configure how we can configure IKV2 based configuration on Cisco ASA. So the configuration on Cisco ASA is pretty easy, and we have covered everything, the technical steps. We have covered it in the slides as well. If you want to get to the details, you can always refer back. I've just pasted each and every aspect of the configuration on the AS in the slides. Coming back to the configuration on Cisco ISE, let me log in. That's my lab where we have configured Cisco ISE. Network devices, ASA. The first step I did, I basically configured a profile for ASA. Just configured a secret key. Followed by I configured the authorization policy, authorization profile, Ops VPN. And I did nothing except defining the group policy name. What I say that anyone who's authorized using the authorization profile Ops VPN, he will get a group policy on the VPN, which is this. Cisco Ops VPN group policy. That's the group policy you will get once you are authorized and get an authorization profile uh, on the ISE. And finally, the last step is configuring the policy. That's the authentication policy, where the NAS IP is 1111.55, 1111.55, and the tunnel group is default RA group. Default RA group. And it used the certificate-based authentication. And under the authorization policy, we say that we created a VPN rule. The name of the authentication policy uh, is VPN users, and the authorization policy is VPN rule, where it says that the user should be part of Cisco networking and operations. If I go back to my domain controller, That's my domain controller. There is an AD group operations, and the member is Vinod. You can see that, right? So if the user is part of AD group operations, which is coming from a Cisco ASA, which has an IP of 11.55, if these two conditions are met, then he will get a VPN profile and ops VPN, which basically assign a group policy to the users. That's pretty much the configuration we have, and finally the configuration what we need to do on the endpoint is basically so if I think I already showed you. If I go, the first is the certificate based configuration. Oops, sorry. uh, Gosh. Certificate, personal, user, finish, okay, current users, personal. So this user Vinod has a certificate which has a private key installed on it, issued by a Cisco CA, and which this certificate will be used this certificate will be used by Vinod as a to authenticate and to get authenticated over the VPN. And finally, we need to create a VPN profile. VPN to cisco.com and click create. I've already created it, so I don't want to create a duplicate one. And if we just press this button, create, that's the only configuration we need at this point. That's it. Click create, and your policy will be your profile for the VPN will be created. Since we are using Windows-based VPN client, we have to follow these steps on the user machine. So once we are done with this, we have to go back on the user PC, CPL, go back on the EAP VPN, and under the security section, we have to make sure that IKEv2 is selected, and EAP smart card in EAP is configured. Click properties. And under the properties, you can select this option. I haven't selected to verify the the certificate of the ASA, but it is completely optional. You can definitely do it at your end. There is no option. And you can select the certificate issuer as well. That's it. That's the configuration we need, guys. Finally, we have to test the connection. Click connect. It's connected. If you go back on the ISE and check the logs, it says that it is authenticated using the authentication policy VPN users and authorized using VPN rule policy. EAP TLS, default RE group. That's pretty much it, guys. I hope the demonstration did help you to understand the complete solution we have. And I hope the session would have been informative. And if you have any questions, you can definitely leave a comment in the video in the below, and I will try to respond back with any questions you may have. And I thank you for joining, and I hope the session was informative. Thank you.